This is section 8.6, solving rational equations. This is part 2. We're going to solve polynomial rational equations now. Some directions on how to give your steps here as we look at this. Again, we're solving polynomial rational equations. So the first thing we're going to look at here is that's a little bit different than monomials, is that we have to factor out all expressions in our denominator if it's possible. It's the very first thing we want to look at, okay? Because that's going to help us, again, find a common denominator, which is step number 2, identifying your common denominator of the fractions, okay? Once you identify your common denominator, then you'll be able to know what you're going to multiply your equation by. Once you've done that, once you've found your common denominator here, we need to identify our extraneous solutions, or our domain, okay? And I'll put this down here again as well. This is our domain to start. We don't check for extraneous solutions until the end, but we do have to identify our domain. So that way, when we look at our domain with our answers, do they match up? Okay? Do we have any issues? Fourth, we're going to take the common denominator, just like we did the other day. Take your common denominator, multiply the whole fraction by the common denominator to eliminate all fractions in the problem. Distribute to every part of the equation, and then now you're going to solve what you have left. Again, you might be a simple linear equation, or it could be a quadratic equation with a squared term. Okay, so really it's the same type of thing, except for the only difference is you're going to have to do some factoring at the beginning, okay, to solve it at the end. So let's take a look here at our first example. Example number 1. Okay, so as you look at this example, you'll notice that as you look at the denominators, we don't have to factor anything out. They're already factored. You can't factor anything there. So the parts of our denominator are x plus 1. That's it. That's the only thing that's in the denominator. So that's what I'm going to multiply each side by. Is an x minus 1 all over 1. And again, I'm not going to distribute anything until after I've canceled all my stuff in the fractions. So distribute here, here, and here. So this is 6 times the quantity x minus 1 equals 1 times, or sorry, it shouldn't be x minus 1, it should be x plus 1 is the common denominator. Okay, so 1 times the quantity x plus 1 over x plus 1, and you'll notice I leave the 1 there. You'll see why in a second. Plus an x minus 4 times the quantity x plus 1 all over an x plus 1. Okay, now that I've done that, I'm going to identify my domain. And my domain says x cannot be negative 1. That's it. Okay, that will make the denominator 0. So, again, now as I'm looking at this, I'm going to go through and cancel. Over on the left side of the equal sign, there's nothing to cancel. 6 times the quantity x plus 1 equals. These x plus 1s cancel. That's why I leave the 1 there so I don't forget it. Some of you are asking the question today on if I cancel everything out, does it become 0 or 1? That's why I leave the 1 there. These x plus 1s cancel out, and I'm left with an x minus 4. So now I've got to distribute and combine my like terms. Okay? Now I'm just going to solve it just like a normal equation. Subtract x, subtract 6, and then divide by 5, and I get x equals negative 5/9. This is my answer. Now, the part where it's a little bit different on these is we have to check for extraneous solutions. Is your answer the same as your domain, in other words? If your answer is not the same as your domain, then you're perfectly fine. So like here, we've got x equals negative 9/5. So it's not negative 1, so we're okay. That's our answer. Okay? If it were happen to be x equals negative 1, we said up here that it can't be negative 1. So therefore, our answer would be, in this case, no solution. or the fact that -1 is an extraneous solution. Okay. All right, let's take a look now at example number 2. Okay, this one's a little bit different because we got some factoring to do. If you look in the denominator, here we don't need to factor. Here we don't need to factor, but here we do. They both have an x in common with an x plus 4 left over. So the parts of the denominator are an x and x plus 4. Those are the things that are in the denominator. You don't have to write them down multiple times, okay? So my common denominator is going to be the quantity x times x minus, or x plus 4. All over 1. And that's what I'm going to distribute here, here, and here. Okay? So when I do that, on the top over here, I get an x times the quantity x plus 4 all over x plus 4 equals x times the quantity x plus 4 times the quantity x minus 4 all over x times x plus 4 plus 6 times x times x plus 4 all over x. Okay, domain. X cannot be, in this case, I've got an x in the denominator, so in order to make that, it cannot be 0. And I also have an x plus 4, which means that value right there of x cannot be -4. Okay? Now I can start to cancel. So, when I go to cancel, I cancel out here and here, and I'm left with an x. These two cancel out with these two, and I'm left with an x minus 4. And this x cancels out with this x, so I'm left with a 6 times the quantity x plus 4. So now I need to distribute. Combine my like terms. So x is going to equal 7x, x and 6x, and then plus 20, because 24 minus 4. Now if I subtract 7x, I get -6x is 20. Divide by -6, and x is going to equal -20 over 6, which I can't leave that as my answer. I do have to reduce that. It could be -10/3, or if you want to make it a decimal, it'd be -3.3. Okay, again, we have to check our domain. Is our answer anywhere in our domain? No, it's not, so our answer is just fine. Okay? All right, this concludes part 2 of section 8.6, solving rational equations with polynomial denominators. Okay? Don't forget to take a look at part 3 as well.